Okay, once more, please.
Okay, Trivandrum Lab. Okay, I thought the Fab Lab Bombay. No problem.
Okay.
We'll start with Fab Lab Trivandrum.
Hi, Pratna.
Hi, good. How are you?
Fine. How are you?
Good.
Okay, so can we start? We will go to our page, the group page.
Okay. Just wait, I will share a screen.
Are you going to do it, or we have to do it?
Yeah, I'm just going to open it.
So none of us have updated our individual page.
Really?
So we will be doing that.
What should I say now? Like,
We managed
Please excuse
to.
us for this week.
why? I'm not going to give excuse to anyone, especially for this.
So whatever.
Like we have
Machine building. കാണുന്നില്ലല്ലോ. Right.
But who is going to present the machine week in front of me?
Yeah, got it. So now I have to broadcast this one. So broadcasting. It's already sharing. So you can see it now.
we can see.
Right.
Yeah.
Okay, so this is mechanical design. So we have one single page for both the weeks. Mechanical design and machine design. So this was already explained to you before.
Last week.
Yes, so we just updated this table which is the job allocation for each of us. So you can take it.
So I just want to see the final video and the PNG slide.
All right, okay. So scroll down, and you can see here.
Okay.
So this is what our FabArm is doing. The first two videos, it is like mopping the floor. And you can see the linear guideway also here, to and fro, and including some FabArm station as well.
Nice.
The other videos you can see, the arms and shoulders in moment for that FabArm. And we have used a different end effector for that. One is an electromagnet, we can place objects, and another one is a pen, which will draw whatever lines, something.
Okay. So, are you using or Arduino?
Sorry.
Which controller you have used?
We are controller means we are using both stepper and the servo motors. Stepper is controlled by Gestalt,
Okay, great.
and servos we are using Arduino board.
Okay. Okay, and have you uploaded on your individual page?
No.
So first, you all need to link your group assignment to your individual page.
Yeah, we will be doing
That
that.
is a very
Now only we
important.
are good completed, so now we will start updating our individual.
Okay, no problem.
I think that is all from us.
Yeah, okay. Who all in lab?
Okay, thank you.
Yeah. Yeah, who all present in the lab? I want to see.
Okay, in the lab. So I just stopped sharing.
Okay. Okay.
Can you see us?
Yes. So only 4 are there. No?
I'm from remotely.
Yeah. I saw said. Okay.
And that is Anand.
I know. Yeah. Okay. So I know about Ajit. He's actually he has studied with me. Yeah. Okay, then all the best. But start do your individual assignment. Yeah, and one more question. Who is going to present tomorrow?
That's not a
See, who is going to, like, that page should be checked by Neil. Individual assignment going to check by Neil. What is your individual contribution you need to tell to Neil?
Okay. Okay. Everybody else is there.
Yeah, so discuss it and
I guess
Everyone has to see.
Srijit, they're present.
Do we have to make a video, 1 minute video, and then we just play the video, or is it somebody presenting it?
yeah, so actually one student need to present and he's just going to check your video and PNG, and then one person need to describe everything like how you do and bill of material, all that things.
Okay.
So
Okay, we'll decide that. We have not yet decided that.
okay, then be ready with it.
Okay, thank you.
Yeah, thank you. Bye.
This is there. So come and see what's there.
Mahavir, yeah, okay, hi Sibu. Yes.
Yeah, go now. Like, we will show instruction. They will show like instruction.
Okay. Have you shoot?
What?
Like, have you shoot the actual real-time video?
No, you can see the telescope in the back.
Ah, yeah, it's nice.
Okay. So we will show, and maybe like, what do you want to do? Like, first show the website, and then go back to the demo, or other way.
I'm a bit confused. Like, you are going to.
Let's show the telescope first.
website.
Okay, then we want to go other way. You want to see the website.
No, screen share.
So, what to do? Like, we will share the screen.
Yeah, please.
Group page open in the page.
Okay.
And open it.
Can you see the screen?
Yes.
Oh,
Very nice.
I'm just trying to find my page. Okay. So you want me to present my page first and then move on to the group page, or how is it?
Okay, first we'll start with group page and then we'll go with your individual page.
Okay, fine. So this week is machine design. Actually, the group page is not completely done, so that's fine. Okay. So yeah, starting with machine design, like this week was mainly to automate the telescope. So before making the telescope understand how to move, we had to learn how actually it works. So I learned a lot of astronomy. So that is a lot of need to resize it.
Nice.
We find
Tanvir, you're not audible.
that this
साउंड नहीं आएगा
can you hear me now?
Okay, I can't hear you properly. There is some drop in audio.
Refreshing. Okay, one second. Yes. 1 second. Page refreshing. 1 second. Yeah. Okay. So this is all the calculations that I've done. All the what's okay. Okay. Like all the stars will be given on a celestial sphere. So we need to convert that to our local coordinate system. So this is the calculations that has been done to convert that things. And like this is all the basics on what is an hour angle and what the calculation behind it and the equations for it. So this is how we making the machine understand is what we get out of these calculations are degrees, and we need to feed steps into the machine. So that is the calculation which is done over here. Moving on to electronics and programming. Like these are the new components we have used. These are RAMS board, Fundino, and the Pololu stepper motor. These are the basic electronic components we have used. and this is the program. This is a full-length program that I have written. I'll explain in detail when I go to my page. This is a really big program. This is all done from scratch. So yeah, it took a lot of time. So this little more to be added to the group page. So I'll not explain more on here. I'll move on to where I've done bit. Okay, let's continued with last week's with last week itself. So this was where we started last week, and this week we got a telescope. So I needed to print a holder for this telescope, for this pipe, right? What we see over here. I needed to print a bracket for that, and this is what I did. And like I just explained, like I circled these parts to show like why there's a square over here and why there's a fillet over here. Those things have been explained over here, like the design thinking between that. This is me and Lancy fixing the telescope onto the side arm, balancing it and seeing whether it is correctly aligned. And that's the mechanical part that I've done this week. And then moving on to programming again. This is so this picture will actually make you understand easy. Like the outer sphere is actually the celestial sphere where all our stars are, and what we get is a celestial coordinates, and we need to convert this celestial coordinates to our local coordinate system. That is the main brain or the main backbone of this program, is conversion of celestial coordinates to our normal coordinate system. So this is the programming part. So initially the inputs that the program asks are the declination angle, the right ascension angle. These are some terms that is like we call latitude, longitude. Like for stars, we call RI and declination. So these are the two things that we get as input. We give our time, our latitude, our longitude, and the current date.
Okay.
So this is actually this big number. Two big numbers are the latitudes of Fab-Lab-Kochi. This has been stored as a static value. We can change whenever we are changing to any other location, and this give the time and whatever the date it is today. Next, we need to convert all these above values. Like all these values are given in degrees and minutes, hours and minutes and all. So we need to convert those to decimal values. So this is the code for that. Then there is something called J2000 and vernal equinox. That like right now America is following daylight saving time, right? So that started from March 21st. So that is the why do they do that daylight saving, and that March 21st is actually called the vernal equinox, and that is the day, and there's some importance to that. So I've explained a bit on that. J2000 is actually January 1st, 2000. That is the reference time in which all these coordinate systems have been defined. So again, like this is the number of days from the start of the year to the current month. So these some certain terms that are required for our calculation. So I just explained on why it is important and like how we will use it in our program. So there's something called local sidereal time. This equation is given here, and that this is the program for that, just to calculate the local sidereal time. And there's another thing called hour angle. This, once you read about these things, you will understand like what is hour angle and how to do that. And this is the small program to finding the hour angle. And now once we get all these values, then we find altitude and azimuth. Altitude and azimuth is the local coordinate system. Like I told you just before, like RA and declination is in a celestial sphere. So altitude and azimuth is in the local system, we reference it like that, like the x-axis and the y-axis of the star. This is called altitude and azimuth. So again, this is another sign equation for finding that. Just find the inverse of this value, you'll get the degree value. Same thing for the azimuth also. There is this equation. Just find the inverse of it, you will get the degree. And then as I told in the group page, just convert these degrees into a number of steps and feed it into the motor. And this is what we are all assembling together yesterday night. It was an all-night work we had yesterday. And yeah, so it's complete. So I'll just show you the live demo of it, because yesterday was I think new moon or cloudy night. We couldn't find moon yesterday. So hopefully today we are looking out for one.
Okay, great.
Yeah, so I'll just show you the live demo.
So today you're going to check with your telescope.
Yeah.
It's quite interesting.
Yeah. So you can see that.
Yes.
Okay. Yeah. So this is right now. It is actually finding the home position.
Okay.
Okay. So like there is this has to first be aligned to 0 degree north, 0 degree north, 0 degree azimuth, and 0 degree of the top part. 0 degree azimuth and 0 degree on the top. So
Okay.
wherever it needs the positioning switch that's down here.
Mm-hmm.
This is see there's a switch over down here. So you can see one nail that is below that will come and that will be the zero position of it.
Okay.
Recognize that as the north. This is the north. This is the north pole.
Mm-hmm.
Okay. So yeah, so right now it's going to it.
Yeah.
Now next we go and align this one.
Cool.
See now it's going to go up and go point to the zenith. Zenith is the 0 degree north vertically upwards.
Mm-hmm.
Same similar step over here also. Here we have another switch over inside here. The screw is going to go and hit over there.
Okay. Yeah.
That's going to hit the zero degree altitude. Okay. So now once that is done, then it will start moving to the position of the moon. This is 0 degree. Now it's turning to 40 degree. I think. Going to the moon's position. Now, once the azimuth is set,
Mm-hmm.
next you get the top altitude also. Now, if you view it from here, you can see the moon. So that is the.
No, lot of study and effort. I can see. Good. Yeah.
Thank you.
Very nice. Congratulations, Kochi team. Super. So you are going to head out today, actually? Or still there is cloudy weather?
Yeah, I think so. Yesterday we couldn't find the moon, so hopefully we'll try today also.
Good. Nice. So one big question. Have you updated your individual pages? What efforts you have taken?
Yeah, I have done like I think couple of days.
No, not everyone, but they have done something. So they will all complete. tomorrow.
Okay, no problem. Okay. But anyways, very good. I'm very happy to see.
Okay, thank you.
Thank you. Thank you. Dipali, are you there?
Hello, Pradnya.
Hi, Dipali.
Yes. We have uploaded our page.
Okay.
Abhijit will explain.
Okay, no problem. Tell him to explain.
Pradnya, go to the labs, go to our page, lab.
Okay, just wait.
Walbot. Go to Walbot. Go to Walbot. Yeah. So
Abhijit, you need to send mail to Neil as well, okay?
we have sent a mail to.
Okay, no problem then.
Yeah. So we were going around few ideas for our machines.
Mm-hmm.
So there were some machines we were deciding on. So this is one automated embroidery machine. Uses this automated action of needle and thread. Then this was a multi-end effector machine. So you have milling, wood milling, or a laser head at the same time. And this was the Walbot machine, which will paint the walls of the building. So so we decided on doing Walbot. So this was our team. This is the contribution that we did. We have not uploaded the video yet. The video is done. We uploaded to YouTube. I'll link it to the page. So this is what we did. We started with very simple XY coordinate, just to know the whole XY works. So this was our first rough trial. I have to edit this image also. This is large. Right. So we did a basic mount for the motors. So our machine is going to use two motors to do the.
Why you put this such big image over here?
I don't know. I have to edit this. This was a
Okay.
mistake.
Okay.
Okay. And these are our CAD files. We did a CAD rendering. CAD designing in SolidWorks. And then this is our end effector on the right corner top. So actually we want to include a spray can, but right now we are trying with the pen
Okay.
line drawing. And then what we did was we did not want to limit our canvas, because if we do a frame for X and Y, then we are going to limit our the size of canvas. So we just did a frameless design. We just did two mounts for our two motors, and then this third, the top right corner, is the end effector.
Okay.
And then if you so then comes the firmware and programming. So Supriya has already done for a machine. She has used Marlin for Rangoli making machine. Rangoli making machine. So this is just a representation of how we went about searching for the firmware and software. It was with Marlin. So Marlin we use Arduino Mega board and RAMs 1.4 for that, and then you configure the firmware according to the machine. So what happens here is Marlin. There are a lot of features or a lot of codes which are related to the bed temperature, the temperature, and so on. So they are related to
Yeah, that
the
is
movement.
basically for the 3D printer. So you need to change that temperature
Right.
setting and extrusion.
You have to do a lot of debugging here and there. So I've explained here how you comment of the features which you don't want and on, and then the below image and then you set the baud rate, you set the motherboard and all, and then this is the connection of RAMs 1.4 with our this thing. There's no thermal, there's no heat bed, there's no any other thing in our machine. So this was getting kind of complicated. Still explained how you get the G code out of Inkscape. You download for Inkscape, and the whole procedure of you make a path to G code and all. And then we came to a conclusion that this particular firmware is not suitable for a machine. It was getting debugging was a real problem. Then we just switched from Marlin, and then we went to some other firmware. So there were two firmware which we were particularly interested. There's Polar Graph SD, which is open source. There's one called Michelangelo. It's a tough pronunciation. So Michelangelo. So the second trial was with again Polar Graph.
Okay.
So even Polar Graph requires RAMs 1.4 and Arduino Mega. And then we uploaded the code, GitHub link also for this. So there was error in uploading.
Okay.
And then it went on and on. So again, error debugging was a problem. Then we went on to, for the third trial, we went to Michelangelo, and for this we had to switch to Arduino Uno and the expandable motor driver shield. So this is working fine. The only problem was when we gave it a 12 volt 1.2 ampere current, which is specified in the documentation. The motor drivers are heating a lot. I have also taken a photo of measuring temperature.
Okay.
So now the machine is working without the external power supply. It is working on Arduino's 5-volt power supply. You can see it nicely. The machine
Do you
is
have
working.
any video to locally?
Come again, Pratnya?
Do you have any video to show locally?
We'll show locally. Okay, we'll share.
Yes,
We'll share screen.
yeah,
We'll share
yeah.
screen.
So I will get idea like how your machine exactly working.
Hello, Pradnya? Pradnya?
Yes, I can see.
Yeah.
Okay,
I'm
so
seeing something. Okay, brainstorming and assembling. Okay.
yeah. And now this is the assembly. Uh,
This is manual.
this is the manual working. What Neil had asked us to do.
Yeah.
You move it manually, and then only your motors are going to move. So you can see the two stepper motors,
Mm-hmm.
and this is the connection of end effector. So this is the GUI of Michelangelo,
Mm-hmm.
which is available online, and then we give the coordinates. And now, yes, see, it's not accurate, or we need to change the polarity of figure out the polarity of the motors and all right now.
Okay.
So we have to do a lot of debugging in that department.
Yeah.
So we have still one more day to figure it out.
Hmm.
I guess we can do that.
Okay.
But it is working. I mean, it is working fine without external power supply.
Okay. So your machine is running with 5 volt.
Yeah, it is running with 5 volt.
Okay. Good. Nice. Yes. Okay. So Mahavir and Nishta is there?
I think they are attending from another.
Chandigarh.
They are attending from Chandigarh.
Yeah, hi, but you get me there.
Hi. Yeah. Okay.
Website is not up, so I'll just get whatever we achieved before we went for Chandigarh.
Okay. So you haven't uploaded any video and PNG?
No, nothing on that side.
Okay. You need to update it soon, like till midnight or before tomorrow morning.
Sure. So, before we left, we basically achieved. We had assembled all the components, and we made it move with an Arduino and a motor driver. But that's all we managed to do. We just managed to make the individual components move. We haven't exactly figured out how to convert G code into how to convert the CNC file into a G code and move forward, because that can only be done when you come back. So we reach Kabul tomorrow.
Okay.
Definitely right now traveling, so we will be able to explain the other parts.
Okay.
Other than that, just one second. Hello.
Yes, I'm just checking
Yeah.
your images.
Yeah. So, Jatan and I and Nishta's the last day we're going to stayed up all night to work out and actually print the newer version. So Jatan designed it on SolidWorks, and we printed it out, assembled it together. Unfortunately, it wasn't the best fit, so we used a lot of glue gun to join it together. But
Okay.
more or less, it was perfect after assembly. So I don't have an assembled picture of the printer right now.
Okay.
But more or less, it was a very system. And that's
your
all we have.
electronics and programming part is done.
Sorry.
Your electronics and programming part is done.
Electronics part is done. I mean, it all works out fine with Arduino. Only thing is the programming part requires us. I mean, we're not being able to convert a, let's say, a 3 object file into a G code which can be understood by the machine. That's something we have to figure out. But as such, we're able to move it and carve out together.
Okay, no matter. Just whatever you have done yet, you need to upload it soon. Okay.
Yeah.
Okay. Have you informed Jatin or someone from Vigyan Ashram to update your your machine page?
Yeah, so machine page is still developed. It's the only thing we're not able to update it.
Okay.
Upload.
Okay. For uploading, you just need to mail to Neil.
No, Pradnya.
Yes, Suhas.
Suhas here.
Huh.
Yeah, so they will update all the pages and they will send to me. Then I will
Okay. Okay, no problem. But yeah, we just need to complete it before tomorrow's class.
Yeah, sure.
Yeah, we'll do that. Sure.
Okay then, good. And yeah, also don't forget to link your individual assignment page with your group page and your group page with your individual assignment. So that you all need to check.
Right. So we'll do that, but the only thing is we won't be presenting a complete machine. I mean, the machine won't be complete, but that's for sure.
Yeah, but for now you can put your whatever you have done or whatever the work in progress video also good.
Yeah, right. So we just prevented whatever is available with us, we'll present it, and the website will be up. So all those things will be up in the individual pages and the machine page.
Okay.
Documentation will be done on the part.
Mr. I can't get you properly. Like
I'm saying the documentation will be done before the
okay.
class. Yeah.
Yeah. That is the important thing. That's it.
Okay.
Okay then. Thank you.
Thank you.
Yeah. So Lavina, are you there? Okay, I think she's not there. Anyways, for all students, we actually just recently we have done with mid-sem evaluation. So all you need to improve your assignment as per the reviewer comment on your each and every assignment. Okay. Suhas, are you there?
Yes, yeah.
Yes. So have you checked with Arundhati's page? She have uploaded almost 196.
Yeah. So I told her to just be looking on this. So he will do it.
Yes, Pradnya, I'm here.
Yeah. So just Arundhati, check with your website and yeah, try to reset it soon.
Yes.
Okay. Okay. Thank you, Arundhati. Okay. Hi, Lavina. Lavina, I can't hear you. Lavina, you are not audible. I can't hear you. Yeah, I can see you, but I can't hear you. No audio from your side. Okay.
Hello.
There is a echo.
Okay. I don't know what is happening.
Yogi, can you please check with your laptop mic setting? It might be internally because I can see you, but I can't get your voice. Are you using Ubuntu or Windows? Windows. Okay. We'll wait. Yeah, now I can hear you, Lavina, and there is no echo too.
Okay. Yeah, great. Um, just a minute. We'll fix our machine up. Um, are there any more groups to left for review?
No, everyone has
Okay. Actually, there's some problem going on here. So we're trying to fix that.
last minute mess.
Yeah, last minute mess.
You are not audible again. Yes, now I can. Yogi,
Okay.
help me now.
Yes.
You are
Yeah.
an instructor.
Oh, so can you hear us now?
Yes, now I can.
So we will be trying to work on an XY plotter. So what happened with the mechanical part is we made a smaller version of it and it was not working. So we made the new thing again this week. So
Okay.
so to fix the whole mechanics again. So now we just we've done a trial run on the earlier version. So now since the belts were not balancing and there was some level differences into it, so we had to re-laser the whole thing and start the mechanical part again. So now we have almost fixed it and just a run in
Okay,
the
what exactly your machine going to do? Like it's simple XY plotter or different one?
a simple XY plotter. We tried to work on a game earlier, so we did some testing for a snake and ladder game, but calibrating it was becoming a little problematic and a lot of equations came into plot which we could not handle with time. So we decided to do stick to the pen plotter that we have, assemble that and fix it as a machine, and then progressively go to making a game or something on those lines.
Okay. I think you need to very clear about the application of your machine.
Right. So there was a lot of discussion we had over it. So we wanted to make a game, but since the calibration was becoming a little difficult with the snake and ladder blocks, because there were 100 blocks to probably calibrate. So we moved to something like probably achievable a pen plotter. We'll draw drawings with the pen plotter first, and then if we can progressively do that in the next month's time, we will try to do that. Else we'll stick to the pen plotter.
Okay.
So yeah.
So have you uploaded documentation of this machine?
So the first one we have almost accomplished with pictures, but this one, since we have to redo the whole process and there were some parts which were not available, so in the process it has taken more time.
Okay, but try to do parallel documentation because time is very less.
Right. Agreed.
And yeah, you also need to do your individual work as well. Like how you contribute for this machine. So you, Gavrang, Raj, and Amit, you all four need to concentrate on this as well.
Okay. Fine. We'll
Okay.
try to update our pages by tomorrow evening.
Okay. And also, yeah, do check with your evaluation.
Yeah, for sure.
Okay.
Yeah. Thank you.
Thank you. Okay, then I think see you all tomorrow. Yeah. Bye.
Bye.
Say it.
Size is not so noted. Size logo is the data, geo data.